He should get hipster glasses. So what's going to happen here? What can you expect from this talk? We're going to be discussing the parallels between music and code. And you're going to learn how the brain of a musician might actually be similar to the brain of a coder. You're going to learn how we break elements down to learn. Keep on talking, okay. How we use patterns to build, how we use creativity to problem solve, and how we use persistence and flexibility to grow and succeed. And hopefully you'll walk away from this talk thinking that, hey, being a musician might mean that you can be a better coder, and being a coder might mean that you could be a better musician. So I want a little audience, actually I'm going to go back, I want a little audience participation before I tell you who I am. I want you to raise your hand if you sing or play an instrument. Take a look around. That is pretty amazing. That is almost everyone. It is absolutely insane. But I have to say I'm not that surprised because I am a former professional opera singer. And when I tell people that, they're like, oh yeah, there are actually a lot of musicians that I work with. We actually have a few guitars in the office. And I've been told that so many times that I'm like, okay, there's something here. And the more research I do into this, the more I see that, yeah, there's a connection here. And there's scientific research as to why. How did I get back here? I just present things. Okay, this is who I am. I'm Catherine Meyers. If you want to tweet at me about my talk or anything, my Twitter handle is ccmeyers324. You can always email me at cmeyers@mavenlink.com. Like I said, I'm a former professional opera singer turned software engineer, and I work at MavenLink. And everyone, we're hiring. Yay! So you can go to mavenlink.com/careers. We have offices here in Salt Lake City and San Francisco, where I work. So will everyone who works at MavenLink raise your hand? Yeah, we're like taking over. So come talk to us if you're interested in moving. It's a really cool place to work. Also, my slides can be found at bit.ly, music, code, Ruby. So I mentioned some science, and that's where I want to start, because I know my audience. I know who I'm talking to. A bunch of engineers, and we like science. And there's been a lot of studies done on music and the brain, on the effects of music education and the brain, listening to music and the brain. And they're done by really cool, impressive sounding publications with words like neuroscience and lots of other medical jargon and doing really cool things. And like this one that was studying jazz improvisation, they actually built a metal-free keyboard so that they could study the brain of a jazz pianist while he was in an MRI. Like, how cool is that? And I was just blown away by how much was out there. There are articles, if you Google music in the brain, so much comes back. So I want to share with you some of my favorite cold, hard fun facts from the research that I did. And the first is about the central sulcus. So that's a part of your brain that decides whether or not you're right or left-handed. So the central sulcus is a part of the brain that will actually be nested deeper into the left hemisphere if you're left-handed, or nested deeper into the right hemisphere if you're right-handed. And while they were doing research on pianists, they found that overall these pianists had pretty symmetrical central sulcuses. Sulci? And these pianists didn't identify as ambidextrous. They actually identified as right or left-handed, which left the scientists to conclude that this was not a natural symmetry. They were actually born with it deeper right in the right or left side. But through all of their musical training, they actually made it more symmetrical. And that's because pianists use both hands, right? And they're constantly working to make sure their weak side is as strong as their dominant side. They're strengthening both sides to be the same. How cool is that? That they're physically changing their brain with musical training. The next fun fact just makes me feel nice on a bad day, that learning to play an instrument is linked to a higher IQ. And they did this study with 2 separate groups, children and adults, and the difference was definitely greater with children, but it was still there with adults. So anyone who doesn't play an instrument now, there's still time. You can raise your IQ. Maybe you can convince your boss that this is professional development, because you can be raising your IQ. The next is probably the most well-known group of studies done around music education's ability to enhance speech and language development. And this is pretty popular because it's brought about a lot of, Mozart and music and babies and mommy and me classes for infants, and people are like, why do babies need to have music? And it's all out of this research. And specifically with speech and language, it's because when you're creating music, you're using the parts of the brain that connect sound with meaning. So if you're practicing that in music, your child is going to be faster at speaking and communicating because they're already using that part of the brain. And our last fun fact has to do with IBM. So back before the days of computer science as a degree, IBM used to recruit music majors to hire as programmers. A journalist found a pretty cool ad targeting music majors from 1956. So CS degrees came along a little bit later in 1962 at Purdue. But what are they going to do prior to that, right? They're going to go to math majors, but also they're going to go to music majors. And I thought that was pretty cool. People saw this connection way back when. So who am I? Why am I talking about this? Why am I so passionate about this subject that I'm going to stand in front of hundreds of strangers and talk about this? Well, I don't have a stereotypical background for a software engineer. I didn't grow up loving computers. I didn't play video games. And maybe while some of you were building computers as kids, I was wearing sequins and singing show tunes and giving you jazz hands. And I started my music education in elementary school, and my music education was started with public school music education. So can I stop here right now and give a shout out to public school music education, right? I honestly don't know where I would be today without those early years of music education. It's where I learned to play the recorder, and then the violin, then the flute, and then I begged my parents for piano lessons. And it was actually in a 6th grade talent show where I was singing something from Cats that my 6th grade music teacher took my parents aside and said, you should think about voice lessons. And that was a life-changing moment for me, because without that, I don't know if I would have taken voice lessons or gone the route I did. That moment led me to my first career as a professional musician, and I found out later it prepared me for my second career as a software engineer. So after I took some voice lessons, I decided, yeah, I love this. I was introduced to classical music for the first time, and I fell in love and decided I wanted to do it as a career. So I went to school for it. I went to Boston University and got my Bachelor of Music from the College of Fine Arts there. And then I moved to New York City and got my master's degree in music from Manhattan School of Music. And from there, I entered the world as a professional musician. So what did that mean? It meant I got to do a lot of really cool things. I got to create music with other amazingly talented musicians. I got to do this on stage and just create beautiful music. And I don't know, I'm sure you guys know that feeling, that thrill of creating something from nothing especially in the music world. It is like no other. I also got to sing in some pretty cool venues and for some pretty cool people. And I loved it. I loved the part of my career where I got to create music. But there was another part of that career. There was the reality of having a career in this industry. And it meant I was working multiple jobs and still not sure if I could pay the rent every month. It meant that I was sacrificing my personal life to travel for auditions and gigs and competitions, and I was sacrificing time with families and friends. I would actually have to say no to weddings because I had a gig, and as a musician, you don't say no to gigs. And so as I neared 30, and I'd done this career for the entirety of my 20s, my priorities were starting to shift, especially as I was starting to envision my life with a family. And I realized I was living a life that I no longer wanted and I didn't want for my future. So I made the hardest decision of my life, and I decided to leave the music industry. And I spent a year trying to figure out, well, what am I going to do next? And how did I choose software engineering? Did I see those scientific studies and be like, yeah, I bet I would be super good at this? Yeah, no, not at all. It was actually through the prodding of my friends that I got into this. And actually, a former opera singer, so that guy on the left, that's Tyler. He is now a technical recruiter for Vimeo. And he was the first one to suggest to me, hey, have you thought about learning how to code? And I responded by laughing in his face. I was like, are you kidding me? I'm an opera singer. Like, I'm not going to be good at coding. Like, those are just people that like sit in a corner with headphones and they don't talk to anyone. And it's not for me. And then another friend brought it up as well. And I'm like, what are all these people talking about coding? And then I remembered, hey, well, there was that time I taught myself HTML. I was working at a nonprofit music school, which of course meant they were completely understaffed, so they didn't have anyone to update the website. So I just taught myself HTML so I could update the website. And I actually liked it so much that I started shirking my other duties so that I could play around with the website. And I was like, okay, so actually I did kind of like that. And then another friend told me about these boot camps where, oh my gosh, you go for like 3 months and then you've got a job and look at all this money you're making. And, because that's how it goes, right? And I was like, well, that does sound a lot better than going back to school. And so I stopped laughing at the idea and I started to teach myself how to code, see if I really would like it. And the more I did it, the more I liked it. So then I decided to find the hardest boot camp in New York to get into and apply to that one. So that's what I did. And I went to the Flatiron School in New York City and loved it. And after that, I started working at Red Antler, which is a branding agency in Brooklyn. And I was able to work with incredibly talented designers and building really cool websites. And then I decided I missed working with data. And also I wanted to move to San Francisco. And that's where I got connected with MavenLink, and that's where I am now, and absolutely love it. So music and code. Let's talk about the parallels now. I want to go back to the beginning, to the learning process. And that's where our similarities start. Because this is a pretty simple song. Who already knows what it is? Don't tell anybody. Yeah. If you already know it, pat yourself on the back and thank your music teacher. But if you don't know how to read music, this can be pretty overwhelming. There's a lot of lines. There's a lot of like little dots and numbers and other symbols and things that look like colons. It can be pretty overwhelming. But think back to the first time you ever saw a new programming language. That looked overwhelming too, right? But you figured out how to learn it. You broke it down to its simplest elements. And so that's what we're going to do now. We're going to break it down now. How did you learn that first simple Ruby method? You broke it down to vocabulary. You broke it down to syntax. You learned what def means. Oh, and wherever there's a def, there should be an end. You learn that, okay, after that, we put the method name, and then you can pass something through that you can use, and you learn what puts means and why there's a hashtag and curly brackets. You learn all of the vocab and the syntax, and that's what you do with music as well. So first you start out learning the pitches, and you learn that all those spaces and lines, they denote pitches. So that first space is an F, and then the line above it is a G, and you learn about the musical alphabet. It doesn't go past G. We go back to A through G, and then back around again. And you even have mnemonic devices to help you learn. Like all the spaces spell face, and all the lines are E, G, B, D, F, like every good boy does fine, or every good boy deserves fudge. There's so many. Any more? Anybody remember from their elementary school days? So then all of a sudden, oh, you get what it means to have that F on the space, and now you've got an F major scale, and you know how to sing it. F, G, A, B, C, D, F. Was that okay with the mic? Are we awake now? The post-lunch talk? That was my real goal there. Now you know an F major scale. You've learned how to read the notes. Oh, and that scale can also be sung with numbers. F is 1. 1, 2, 3, 4, 5, 6, 7, 8. And then you learn the rhythm. You learn that, oh, if you fill in those little holes and you add stems and maybe a flag and some other dots, you've got rhythm. F, G, A, B, C, D, F. You can also do that with numbers. So then we can go back to our simple song. All of a sudden, you know the notes and the rhythms, right, from that like 5-second tutorial. You all know how to read this now. And you know that that first note, okay, that's an A. A, G, F, G, A, G, 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 A, C, C. What am I singing? Mary Had a Little Lamb. So that was such a simple song, right? But it's overwhelming if you don't know the syntax and the vocabulary. Just like a simple Ruby method can be overwhelming until you break it down to its simplest form. So once you've got all of the notes and the rhythms, you start learning some of the other symbols. Like this one is a rest. That's where you stop the sound for a bit. And I kind of equate this to a set timeout in JavaScript, right? And then there's this symbol, which is a repeat sign. It means you're going to go back to the beginning and do it again. What's that like? It's a loop, exactly. So when you have gotten all those symbols, then you start figuring out how all these different elements work together to form a whole. So you've got this part, which is the harmony. You're going to figure out how the melody works with the harmony to create a whole entire piece. And we have to deal with that in code as well, right? We have lots of different parts that you have to fit together to make a whole. And in a Rails application, you have to know how the routes are going to work with the controllers, which are going to work with the models, which are going to work with the views. Different elements coming together to work as a whole. And this brings me to my favorite point, which is patterns. Patterns are the simplest way I can describe the biggest connection between music and code. And it's actually what led to my aha moment that there actually was any connection between music and code. I was sitting in class one day at Flatiron School, and I was kind of kicking ass. I was doing really well. The instructor was getting us to build an app and asking us what to do next, and I was like, oh yeah, you're going to open the routes file, and you're going to write this. Oh yeah, now you're going to open the controller file, and you're going to write that and that. Don't forget to open that file. And then he stopped me, and he was like, okay, Catherine, so why are we doing this? What's going on behind the curtain to make all this work? And I actually didn't know why. I didn't know what was going on. And I was like, how in the world did I memorize all this crap and I don't even know what's going on? I feel like there's a lot of Rails developers where that could happen, right? Everything's so automagical that you can just memorize all the crap and make it work. Thankfully, I didn't stay there. But I was like, how did I do this? And I was like, oh, I was just memorizing patterns. I can do that. Musicians are trained to recognize patterns, to memorize them, to replicate them. And what is code? It's patterns. Even going back to our simple Ruby method, figuring out how all that works is figuring out patterns. From knowing that if you're going to interpolate, you need those double quotes. That's a pattern. And it gets more complicated, right? If you're going to write a simple CRUD methods in your controller, you've completely memorized those patterns, right? You know exactly how to write that def index, that def show. You could do that in your sleep. And that's just because you've memorized patterns. And you've also memorized the flow of how all of this MVC architecture works and what you need to do to get things working. So we have some more complex patterns in music, right? This is an excerpt from Handel's Messiah. Raise your hand if you know Handel's Messiah. Even if you think you don't know Handel's Messiah, you know Handel's Messiah. Hallelujah, 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 hallelujah. You guys probably know that. That's the Alleluia chorus from Handel's Messiah. This is a soprano solo excerpt from Handel's Messiah. And it might look overwhelming. There's a lot going on. It looks super fast. Well, it is fast. This is a really hard piece. But if you're a musician and you're looking at this, you're going to just break it down. We're going to take these two measures. And what are we going to do? We're going to break it down now. So I've written out these two measures. And a musician's going to see first that this is actually just outlining a triad. So what's a triad? Remember when we sang the F major scale with numbers instead of letters? Well, 1, 2, 3, 4, 5, 6, 7, 8. If you take just 1, 3, 5, you've got a triad. 1, 3, 5, 3, 1. Those are the building blocks of all Western music. And so that's what we got here. We've got a bunch of 5s and 3s and 1s. That's just a triad. 5, 3, 5, 1, 3, 1. Okay, there are a couple other notes in there too, right? Those are just called passing tones, little flair. 5, 3, 4, 5, 1, 3, 2, 1. Okay, we're a third of the way there. And guess what? The next measure, it's exactly the same pattern, just down a step. And look, the next measure is just down a step. And if anyone noticed that they are slightly different, the first one is minor, then major, then diminished. Anybody actually notice that? Maybe? I know that's pretty yeah, you have to read the key signature, right? So yeah, it gets a little bit more complicated. And then you have to fit this pattern with hundreds of other patterns. So there's a lot going on. It's a lot of information processing. Do you guys have to process a lot of information when you're coding? Yeah. So this is a schema from one of the first apps that I made with a couple of friends. I thought it was so complicated at the time. And now looking at my current code base, this is laughably small, but at the time it was so huge. This is an app that we made to connect musicians with chamber music ensembles. So we had groups, and we have instrumentations and instruments. And as a coder, you realize that you have to keep a track of a lot of things. You know that if you change code in one place, 10 other things could break. Of course, you've TDD'd your code, so that's going to catch that. But there's a lot to keep track of. And I realized that my background in music had helped me with information processing. This is one of my scores. It is for the opera La Bohème by Puccini, where I sing the role of Mimi. And there's a lot of stuff in there. And again, it might be overwhelming because there's a lot to keep track of. And you've got musical markings. You've got those phrasings that telling you where the thought is, where the musical phrase is. You've got dynamics, so that PP you see up there in the top left, that means pianissimo, which means very soft. And then you've got this thing that kind of looks like a greater than sign. I'm trying to use my laser, this one right here. It's not a greater than sign, it is a crescendo. It means you're going to get louder. You have to be aware of tempo. At the top it says andante molto sostenuto, moderately slow, very sustained. You also are going to have to keep track of the whole entire orchestral part. This is the piano reduction, so it's meant to be played by a rehearsal pianist, but you have a whole entire orchestra. And if that oboe is one measure late, you have to realize that and not let it mess you up. You also have a foreign language because this is an opera. This is in Italian, so you have to know what you're singing about. And that brings you to the character part. That is a lot to keep track of. You have to know that this part of the aria, Mimi is singing to Rodolfo for the first time. They're falling in love, and she's just telling him, you know, my name is Mimi. And she's kind of just flirting a little bit. But this is the climax of the aria, and this is where she kind of loses herself and she becomes more vulnerable. And you have to know that subtext. You have to know that when she's saying, ma quando lo sgelo, il primo sole mio. But when the thaw comes, the first sun is mine. And she's really getting into her more vulnerable thoughts, and you have to know the subtext of that thoughts. Earlier in the aria, she says, vivo sola, soletta. And that just means, I live alone. But she's not saying, I live alone. She's saying, I live alone. You also have to have your staging. At this point, apparently, I was supposed to cross to a table. And you also have other markings. I was pretty lucky in this production. I was working with a conductor who studied with an assistant to Puccini. And he allowed me to take his score home and copy all of his notes, which the assistant to Puccini took directly from Puccini. So some of these notes are directly from Puccini, which is incredible. So as a musician, point being, you're simultaneously processing a lot of information. And there's been research done into this very fact, and it involves the corpus callosum. There's a great video done by Anita Collins about this. I tweeted about it a couple days ago. And the corpus callosum is that part in the red, and it is what connects the left and right hemispheres. And a lot of people think musicians and other artists only use the right side of the brain. It's all the creative parts. But musicians use practically every part of their brain. And they're constantly sending messages back and forth between the right and left hemispheres. And that's where the corpus callosum comes into play. That is what is used to get messages back and forth. And because musicians are constantly sending messages, they actually increase the volume and activity of their corpus callosum. So what does that mean? That means that they are better at problem solving because their messages back and forth travel faster and through more diverse routes. So they can solve problems more effectively and creatively in both academic and social settings. We know problem solving, don't we? That's what we do every day as programmers. And I think it's it's the most fun part of programming because that's where creativity comes in. You know, with that one phrase, vivo sola, soletta, there are infinite number of ways that you can sing that with different subtexts, with different meaning. And it is up to the artist and his or her creativity to decide that. And for programmers, there are infinite ways that you can get from A to B. And a lot of times this is decided by your priorities. Maybe your priority is speed. Maybe your priority is readability. Maybe it's to be dry, or maybe you just want to be really pretty with your code. But there's always many different ways that you can solve a problem, and I think that's one of the most fun parts about programming. And this is where I also bring in the life skills and how those are so transferable between music and code, right? It's not just the technical things like patterns, but problem solving, kind of important in life as well, right? Also, never giving up. This kind of goes with problem solving. When you are problem solving, you can't give up. If you are working on that bug for hours, for days, and you want to throw your laptop out the window, you don't, hopefully, because you've learned how to be persistent. And musicians will spend hours in a practice room going over the same measure of music until they get it just right. You learn that persistence. You also learn that persistence in life. When I applied to Flatiron School, I didn't get in the first time. They really liked me, but they were like, can an opera singer really do this? Will she like it? And the idea of giving up didn't even enter my mind. I was like, oh, I just need to prove myself more. So I just taught myself more code, went to all their meetups, and got in. The next life skill I want to talk about is the growth mindset versus the fixed mindset. And this is a concept that was introduced by Carol Dweck. She is a professor of psychology at Stanford University. So the fixed mindset is one where you feel like your abilities are fixed. You're good at what you're good at, and you're bad at what you're bad at. You stick to what you know, and you have a tendency to give up if things get hard. I have a feeling there's not a lot of people in this room that fit that description. I have a feeling pretty much everyone in this room has a growth mindset. We are a bunch of learners. That's why we're here today, to learn, right? If you have a growth mindset, you believe that you can always grow and you can always improve, and you enjoy learning. You like being challenged. You don't mind the code reviews that come through because you see it as a chance to learn. And as a musician, you are constantly learning. You have to know how to receive feedback, good or bad, crazy or not crazy. So this really did help me prepare to become a software engineer. Next up is collaboration. And don't we love stock photos? We realize now that collaboration is so important in coding. The days where you could just sit in a corner with your headphones on, not talking to anyone, they're ending soon for a lot of companies. Nowadays, a lot of companies are all about teams, working together as a team, being able to collaborate, pair program. You have to be able to work with others, right? And musicians are constantly working together. When you're in an orchestra, you are listening and giving and taking with hundreds of other musicians. The best example I can give is jazz improvisation. If you go listen to some jazz music, there are solos being given and taken. If I'm taking a solo, I have to know when to give it, and the person that's taking it next has listened to mine and is creating a solo that will complement mine. There's constant listening and communicating without words. You also have to learn how to deal with different types of people. And all the way from conductors who can have very strong personalities to rich patrons that you need to schmooze at the after opera parties, and also be able to talk to your other singers and anyone in the many jobs that you might have. And you need to be able to talk to other people as a coder, right? You've got PMs to deal with, you've got designers to talk with, and it helps if you know how to do that. So lastly, why does this matter? Why am I taking up time at a Ruby conference to talk to you about this? First off, I don't want you to let untapped resources pass you by. My resume looks very different than some other people's resumes. And I want you to see that different background as an asset. Also, diverse backgrounds make a difference. I'm going to come at a problem in such a different way than someone with a CS degree, who's going to come at it from a very different point of view as somebody else. And having those different points of view is only going to make the solution that better, much better. Music education. I have to give my testimony here and again say, I don't know where I'd be without my public school music education. And especially in this political climate where it's seen as such a good idea to slash the arts budgets, I want to be here as a witness and testify to the importance of music education as a software engineer. Also, all y'all, don't be afraid to lean into your musical abilities. Or if you think you have none, try anyways. It could make you a better coder. And lastly, I want to leave you with the thought that our goals are actually pretty similar. A musician's goal and a software engineer's goal. All we're doing is we're working with a team to create something that will be enjoyable to a user. Any questions?
Everybody in this room, of course, knows that diverse backgrounds are important, but let's say you're trying to convince someone higher up to take a new hire, but they want somebody with a lot of hard coding skills because they want to be productive. Produce, how do you convince somebody who might not be as up with it as all of us that it's a good idea to go with somebody with these non-standard career paths?
That is a really good question. We actually started a diversity group at MavenLink to address those kind of questions. And I would have to make the points about the research done on diversity. And like I said, how people coming at the same problem with different points of view are going to solve it in different ways. And that is going to make you so much better in terms of productivity. And the solutions that you're going to come across are going to be so much better. Also, there's been research done as to if you're forced to explain something to somebody with a different background, it's going to force you to explain it in a more complete way. If you're communicating to someone with the exact same background, you can have shortcuts, but that's what they are. They're shortcuts. And if you're forced to communicate with someone who is completely different than you, it improves your own understanding of that thing that you are explaining. Yes?
What parallels have you found between music as a performance art and code as a communication medium? For instance, when I've been on stage for music, it's more than just creating the music, because obviously a computer or just a recording could create it over speakers as well. But it's about me being able to portray some of what I feel and have just for a second part of the audience feel what I feel at the same time. And for me, it seems like a lot of times with code, it's somewhat similar. What are your thoughts on that?
Well, I think that's where the creativity comes into play, right? I think it's the creative parts of music that are the most satisfying, and whether that involves being a catalyst for your emotions and having the audience feel your emotions, that's incredible. I don't know if through building our apps we're getting our users to feel our emotions, but maybe we're getting them to feel our satisfaction, because when we make that feature, I don't know about you, but I feel so satisfied and fulfilled that I did that. Hopefully they think it's as cool, as satisfied as I feel. Did that kind of answer your question? Anything else? Yeah.
Have you tried to program music?
I haven't yet. I definitely, who's done that? Yeah? I really want to. Do you have any recommendations of?
I know there is a tutorial, Haskell School of Music. It's a programming music in Haskell. There's also a package for Emacs that essentially turns it into a synthesizer.
Mm-hmm.
I don't know if there is something in Ruby, but
There's a
number of mini passes.
Yeah.
We had a talk last year on Now West that was about music by Benn. So he actually programmed.
Awesome. Very cool. I feel like that'll be my next side project. Anything else? Yeah.
Who else got emotional off that? Because I did. I'm a musician, and a lot of us are very emotional people. So. I actually cried for a second. I thought it was an awesome connection and correlation that you guys.
Thank you. Awesome. That makes it all the worthwhile.
Right foot.
Also, I can't believe I didn't take my shoes off. I was totally going to take my shoes off. How did I stop the... Wait. All right, and I just want to say thank you so much to RubyHACK for having me, and thank you guys for listening. Thank you.